You're going to find something out real quick today when we do this proofs, but I want you to find it out on your own. I don't want to tell you. Okay, so again, please go to the second one. Mark the angles that are congruent. So I got angle 1 congruent to angle 2. And I have angle 3 congruent to angle 4. QET, need it congruent to QEU, the one right next to it. Okay, are we ready? Same thing. I just want you to get in this mindset all the time. Look at your givens. Are there any full angles or sides? 1 congruent to 2, full angle? Not in the triangles I'm asking you to prove. 3 congruent to 4. So I gave you a full pair of angles. Anything you can do on your own? Reflexive, which side? That gives us a side. This isn't too bad. He's overhyping this. We have 2 out of 3 equal quantities we need. This is pretty easy. Okay, now let's try to find the third together. And remember, have we used 1 congruent to 2 yet? No, and remember, I'm going to give you everything for a reason. Hi. Yeah, I'm listening. Oh, do you have an idea?
Well, if 3 is congruent to 4 and 1 is congruent to 2, that must mean that QB bisects TQU and TBU. So we could use that. somehow. All right. Get this bread.
QB, all right, it's a bisector, but I can't do anything else with that. All right. Okay, here it is today. Ready? Right now, where we are in this proof, we're not proving those triangles congruent. We can't. I don't have enough information, and we can stare at this and stare at this all period long, but we are never, right now in this proof, we are never going to get triangle QET congruent to QEU. It's not going to happen, guys. Sorry. And I'm dead serious. That's not joking around. We're not going to do it at this point in the proof. So what we need to do right now is get our mindset off of proving these 2 congruent and look at the diagram and see if there's another pair we can prove congruent. All right, so you and your group right now, look at the diagram, get off this train right here, and see if there's another pair of triangles you could prove congruent instead. Okay, here we go. Let's get back together now. Did anybody find a different pair of triangles that can be proved congruent right now? Not in step 3, but can be. With all this information we have. Roman, what'd you guys decide on? Got it. So these 2 triangles that are right on top of each other. Everyone see them? I got 2 pairs of angles, and then what else are you going to give me? Reflexive side QB. Yep. So if you want to add that in statement 2, you can. I'm just going to write all these steps out separately. But again, you want to write this in statement 2 because it's reflexive again. You can. And his group is absolutely correct now, yeah? Because 1 was congruent to 2 and 3 was congruent to 4, and you proved the side in between, I can now say that triangle QTB is congruent to triangle. I want to make sure my letters are right. QUB. Yep, by what method? Angle, side, angle, because that reflexive side is in the middle. Nice job. All right, other than maybe a little more partial credit, how does that help me get to the triangles I'm still asked to prove yet? All right, here is the toughest part about today. In these 2 triangles, we prove congruent. Does everyone agree that all their corresponding sides and all their corresponding angles are congruent now? I need you and your group, whatever, to find a pair of sides or angles that are in the triangles you just proved congruent that are also in the one I need congruent. That's the toughest part. Find a pair of sides or angles that are contained in the triangles you just proved congruent, and they're also in the ones in the triangles we're looking for at the very beginning. And that will finish off our proof. All right, find it and try to find it by yourself or in your group. Find the matching pair that are in both sets of triangles. Find a pair of sides or angles that are in the big triangles and the smaller ones we needed. It's got to be a full pair of sides or angles. Full pair of sides or angles. All right, here we go. Did we find a matching pair that are in both sets of triangles? What is that? What are they sides or angles first? Sides, all right. Name the sides. Everybody take a look. QT and QU. They're both in these triangles we just proved congruent and in the 2 we need. So next step right after, we can say they're congruent. QT, congruent to QU by what method here? CPCTC, and that was the missing link to proving the triangle's congruent. And now you have a pair of sides. And now by what method are the 2 triangles QET and QEU congruent? Side, angle, side. Ready? Prove a pair to get a pair. Okay? Prove a pair congruent to get another pair congruent. That's where we are. This right here is by far, I think anyway, the toughest part for you guys today, is finding the pair that's the same in both triangles. Do we see how this works? All right, so if we're looking at 2 triangles today that cannot be proved congruent, don't waste your time. Find another pair that can be. All right, find another pair. All right, that one does not make us great at all. Of course. Oh, yeah. Big day today, huh? Even the boy makes an appearance, or lady, I don't know, I'm sorry. All right, makes an appearance here. Here we go. Where are we going? Let's go. Let's go. Cube. Shatter. Curtains. Pinwheel. Curl. Slide right. Slide left. We all good? Because I want to get going with the proofs. Anybody else? Any other nominations? What is gallery? I don't know. I have no idea what that one is. Is that when you say gallery, is that something where I'll just change it and you're like, that's what I was talking about. That's what I was talking about. All right, let's go. Here we go. Slide right. Curls. 2, 4, 6. Whoa. 1, 2, 5, 6, 7, 8. Pinwheels. Curtains. Shatters. Cubes. Slide left. Slide star. Star. No stars. Okay. Ready to go? So I got Shatter or Promethean Man coming back. Could be a big day, even bigger. Boom!
I knew it!
That was Shatter. There was like no, do you even know what it looks like? Like I could have easily just lied to you and called that gallery. All right, let's go. What a big day in here, huh? What a big day. All right, and if we're not going to have the homework, we got to keep practicing here as much as possible. All right, so great job. All right, here we go. Back to number 1 now. Back to number 1. And anybody listening to this at home, this is for period 2 only. All right, here we go, guys. Here we go. This one's really a little bit more challenging now because take a look at my proof statement. I need TD congruent to RO. So the first thing we need to decide on as a class is which 2 triangles we want. All right, because there's multiple ones. Because if you take a look at TD and RO, I could prove these 2 on the left and the right, or I could do the top and the bottom. Let's keep looking at the givens and see what we have and then make a decision. I have ER congruent to TI. I have ET congruent to IR. And then I have right angles at TDI and ROE. So if we were to make a decision here, which pairs do we have enough information? Well, the most information about anyway. TDI, because we already have a side and an angle, congruent to EDR, because we have a side and an angle. Everyone agree? We okay with those? Because there's no wrong answer here. You could actually do both. All right, but I think right now we have enough information to do the top and the bottom one. And we were given, let's see, TI, that's a full side. Got to do something with the right angles before I put an A next to it. So let's just take care of that now. What do I need to tell you about those right angles? They are congruent. And even if I do end up using HL, it's just an extra step. That's still true. So TDI congruent to ROE. Right angles are congruent. So there's a pair of angles now. So let's just take before we quit, all right, on these two triangles, before we quit, let's just take a quick look. Is there anything else you could mark? Sure, Orion. You can't, okay, you cannot add two reflexes or subtract two reflexes, if that's where you're going with that. Okay? No, that's fine. It's a common mistake, because here's why, ready? Is that where you were going to try to subtract or add two reflexives? Here's why I can't do that. Let's say EI is 10, and let's say this is 4. Okay, take that away. How many units is left if I subtract this 10 from this 4? 6, right? Now, does that necessarily mean that's 3 and that's 3? No, it could be 5 and 1, 4 and 2, so I don't know that they're equal by subtracting the reflexives. Okay? Anybody else find anything in those two triangles? Me neither. So it looks like we'll have to take a little detour. We'll get back to them in a second. Now look at any other triangles that can be proved congruent, possibly. All right, because there are triangles in that diagram that can be proved congruent. All right, we just got to find them right now. Discuss in your group real quick. Go ahead. What two triangles can be proved congruent? Not the two we need, but there are two there. Okay, let's get back. Any triangles up here that can be proved? Vincent. Yep, absolutely. Everyone see these two triangles right here, the bigger ones that are on top of each other. They are congruent, but I have to say that EI is congruent to itself. Reflexive. Then you can say, yes, triangle ETI is congruent to triangle. Let's see if I go ETI. I'm going to have to go IRE. By what method? Why are those two bigger ones congruent? Side, 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 and here comes the toughest part. Can you find angles or sides that are in both these triangles right here and the ones we needed at the beginning of the proof? Find a pair of angles or sides that are in both. And it's got, guys, it has to be full sides and full angles. Don't give me partial sides. Full sides or full angles that are in both pairs of triangles. You can do it. Go through each pair. Hey, the best thing you can do right now, hey, everybody, the best thing you can do right now is to take these two triangles and literally go through every pair of sides and say, are they in both? If it's a no, go to another pair of sides. Go to another pair of angles. All right? Search all 6 pairs right now in those triangles. Okay, did anybody find any angles or sides that are in both pairs of my triangles? What's up, Caitlin? What do you got? Okay, hold on. Let me just mark it so everybody can see it. Here you go. This one right here. Everyone agrees? That's in the big triangle I just proved. And the yellow one that I highlighted at the beginning. Congruent to what, Caitlin? Keep going. That's in the big one. And in the blue one I highlighted at the beginning. I got a pair that's in both. Okay, got a pair that's in both. I just need to say they're congruent. So angle TIO. You could also call it TID, TIE, same angle. is congruent to, what'd you give me there, DER by CPCTC. That was the missing angle we needed. Now go back. The two triangles we selected at the beginning, triangle TOI, is now congruent to triangle RDE. Anybody got a method? Is that, take a look. Here are my two angles. Is that side in between? No, it is not. So angle side. And then finish this proof off because we didn't need the triangles in the proof statement. We needed TD congruent to RO. Woo! How do we feel now, huh? We all right? We feel all right? Prove a pair to get a pair? I don't. What do you want? Okay, he came up again. What do you want? All right, let's go. Let's go. If this had, like, I just may just give up today. Curtains.
Gallery.
Anything else here? All right, here we go. Slide left. Slide right. Cubes. 6, 7, 8. Okay. Shatters. Again. Pinwheels. Curtains. Curl. And the flip. This could be a historic moment. No class ever getting two in the same class. Ready to go. Promethean Man or curtains? That's over. I'm done. I'm done. Wow. Great. Yep. Nice job. Nice. So heated right now. Okay. No homework tomorrow night. All right. It is what it is. I live and die by my rules, so here you go. No homework tomorrow night, too. Wow. I feel like this is all rigged. Like somebody has done this already and rigged it for me. I don't know. All right. Well, I don't know where to go. Really to go, where to go from here. I guess there's only really one place to go, right? All right. Congratulations. What are we getting up to the hype part? All right. Well, I should have did. All right. Here we go. Oh, boy. Here we go now. Try to get through this one. Try to get through this one now. All right, DGC, BGA. All right, this is a given we haven't really seen in a couple proofs, a lot of proofs actually. AC and BD bisect each other. Not what I need. Not what I need right now. Not what I need. I pretty much should just give up, right? Probably give up on life too, but. All right, if they bisect each other now, which pieces are going to be congruent then? DG and, yep, and also CG and AG. Now, that is not a given. We just mark that on our diagram, so please make sure it gets into your proof. DG congruent to, what was that letter, GB down below? And AG congruent to GC. What would be my reason there? Definition of a bisector. And that's a lot of info I gave you, huh? Because aren't those two pairs of sides? Okay, two pairs of sides. Okay. Is there anything else you could see in the? Because I'm going to tell you, this is possible right now. We don't have to prove another pair here. This is possible. And some of you, I can tell you right now, are probably getting a little mesmerized by EF, that line EF in between. Pretend it's not there, and you'll see what I need right away. What do you got, Dewey? Where are they? Name them. What is it? Sorry, I didn't hear the first one. Yep. CGD congruent to AGB. Yep, everyone see the vertical angles there? Do I have enough to say the triangles are congruent now? Yes, I do. What method there? Side angle, side. And yes, now there's a second part which says, prove to me that GE is congruent to GF. Guys, can I just write that in step 5 and say CPCTC? No, because it's not a side in these two triangles. But it is a side in another pair that maybe you can get congruent. And remember what you just did. So can we decide as a class right now, before I let you go on your own, which two triangles can we prove? Which two triangles? Pick a triangle up top first in the yellow one. DGE? Or I don't care, EGC. Which one? Fine, EGC. And what are you going to try to prove it congruent to on the bottom? Watch your mouth when you hear. Watch your mouth here. Because you can't. Hey, take a look. You can't prove it congruent to this one. Because those sides aren't congruent. So you got to try to prove that one congruent to AFG. That's your goal right now in your group right now. That's your goal. Get those two triangles congruent. Hey, whoa. What do you already have? One pair of sides. That's all I gave you. And the fact that you just proved the two big ones. So maybe there's matching parts in both too. All right, so go ahead. I'll walk around, see what you're doing. This will probably last till the end of class.